Welcome back to the ICANN APAC-TWNIC Engagement Forum. The section will begin soon. This section will be deploy RPKI to boost routing security. And we have the moderator, Mr. Paul Wilson from the APNIC, the Director General, and speakers including Kenny Huang, board member and CEO of TWNIC, Taichi Kimura, researcher of JPNIC, and Kaveh Ranjbas, Chief Information Officer of RIPE NCC. So just give us a second. We'll get all the moderators and speakers on stage, and we'll begin the session. So allow me to introduce again. Next section is deploy RPKI to boost routing security. We have moderator, Paul Wilson, and speakers, including the board member and CEO of TWNIC, Kenny Huang, Taichi Kimura, the researcher of JPNIC, and Kaveh Ranjbas, the Chief Information Officer of the RIPE NCC. And we still have two speakers. Two speakers are not on stage, but it will be fine. I'll wait for them for a while. Okay, so we'll just begin and get them on stage later. So please give them a big hand to welcome their section.
Well, good morning again, everyone. Thanks for coming back from such a very short coffee break. Thanks again to TWNIC for this great opportunity to talk about current important issues, and there's no doubt about it at all that security is an important issue for all of us these days. So we're continuing on the security theme. Jeff Houston mentioned before from APNIC's point of view that we do serve the entire Asia-Pacific region, and we conduct surveys every 2 years of the priorities of the APNIC community, the network operators, the ISPs who build the internet, and we try to maintain some understanding of priorities as they change, and security has become the #1 challenge and top priority of our community, at least over the recent years. So it used to be IPv6 actually. IPv6 deployment was listed as the biggest challenge, but in recent years, security is the one. So it's very good to have this extended opportunity today. And in this session, we'll be continuing the discussion about RPKI. Now, you heard plenty from me about RPKI this morning, so I won't be laboring those points too much, but I do have 4 excellent panelists here to talk about the different nuances of RPKI. I think we'll be introducing more RPKI concepts and explanations so that we really try and promote a very good understanding of RPKI. As David said, it's a complex system. Some people would say too complex, but I think we all know that security by its nature actually seems to need to be complex. It's not a trivial challenge at all. So I think we will hear more, which I hope will bring everyone up to speed and really understand how RPKI works and what are its components, and also I think to talk more about the important issue of how it's being deployed and what are the challenges and what are we seeing next. So let me start with the first panelist to speak will be Kaveh from both the RIPE NCC and the ICANN board. And so Kaveh will start with some introduction about RPKI technology and systems. If the presentation is ready. Thank you, Kaveh.
Thank you. Thank you very much, Paul. So, yes, my name is Kaveh Ranjbas. I'm the CIO at the RIPE NCC, and let me quickly take you through some slides. These are not my slides. Yes, these are my slides. So, sorry, I have to look from time to time because I don't have a screen. So yes, this would be a quick introduction of RIPE NCC and quick introduction of RIPE NCC and what's RPKI in basic terms, and of course we will get into more deeper discussions, but I think it's good to have a quick recap. So, who we are, this is basically RIPE-NCC. We manage IP addresses and ASN allocations in Europe, Middle East, and Central Asia. I think I have to say UK, Europe now, with Brexit in place. But so basically, we are the regional registry for that part of the world, same as APNIC is doing for the Asia Pacific. Routing security has been an agenda for RIPE community and RIPE-NCC since long time ago. RIPE in '94, we had a RIPE document. RIPE document is a way that the RIPE community documents basically their wishes or their policies, and basically we defined a common language to describe the routing policies. We of course co-developed standards with the RPKI basically and other security standards with RIR. With other RIRs, and we are one of the 5 RPKI trust anchors. Again, of course, that's natural how the RPKI works. I will get into that. And we also have a validator tool, which I think it wasn't in Paul's slides, but it's one of the famous validator tools, which and it was the only one since some time ago, which was working. So and now it's still available, fully open source. So you have a choice if you want a validator. So how the routing on internet works? In simple terms, network A tells B that I have this network, and network B tells A I have this network, and that's routing in simple terms. The question is, A can always ask, can I trust B? And B can always ask, is A correct or not? So then there was the addition of the internet routing registries, correct? So you still had the same. A would tell B that I have this, and B would tell A I have that. But then the routing registry was a third-party database that you would say, you would document these records. And both A and B could check and maybe trust that record and say, yes, I'm receiving this from B. And I'm looking in that table, which is hosted by someone, for example, RIPE-NCC, and it seems to be correct. So BGP version 4, also from 1994, but the problem remains because the BGP internally, the protocol doesn't have security. And accidents happen. So, for example, fat fingers, they really happen a lot in routing. It's because it's very simple. You're just configuring a network and you're telling the rest of the world, I have this network or this addresses, correct? It's very simple to make a small mistake, and then the whole world will basically, this mistake will be propagated to the whole world, and they will all hear, oh, so you have this network as well, and they might believe you, which means there will be a lot of issues on the internet. So, and there are also policy violations. Or worse, sometimes there are bad actors. So I think the case was mentioned actually, the MyEther wallet, 2018, and it went unnoticed for 2 hours until it was found out an address. In 2018, there were actually more than 12,000 incidents, and 4.4% of all ASNs were affected by some type of routing incident. This is all routing incidents. And 3,000 ASNs victim of at least one incident. And 1.3 ASNs caused at least one incident. And this is coming from bgpstream.com. So, as I mentioned, having a registry is one solution. RIPE database has been one of the well-established old routing registries. This is IRR. This is different from your normal, basically, internet, the LIR registry. And this is basically to document routing. And RIDB is another example. RIPE database is free and it's good if you're in RIPE region, because then there is authorization. So we can make sure that the records you put, statements you make, for example, network A can announce this prefix, actually comes from your own network or from an authoritative holder of that resource, basically, correct? Because we check with passwords or whatever type of authentication that the person who is making this statement has a right to make this statement. But if they're out of the region, basically they can say anything. It's an open database. Same goes for RADB. RADB, you pay, and then you can make any statement. There is no real actual check. So that can be an issue, because a real bad actor can actually go and, let's say, pay RADB or come to RIPE with resources out of RIPE and make any statement. And even if your router checks RADB or RIPE database, they will say, hey, it's fine, it's a registered record, which in reality there is none, because there has been no authorization. This is the accuracy of RIPE Internet Routing Registry. If you look, and accuracy means what's registered there versus what you see in the BGP, in the real routing table. As you can see, actually in Asia, APAC is not well, of course, because, as I said, we basically, our authorization is only for RIPE region. And this is the RADB accuracy, so which is quite different. If I go back and forth, this is RIPE, this is RADB. So then comes RPKI. RPKI basically, we had a bit of introduction. In simple terms, is an authorized statement from resource holder which says ASN X is authorized to announce my IP from prefix Y, signed holder of Y. And X has no role here. It's just like, so holder of Y can say ASN whatever number is authorized to announce my IP prefix. That's basically what RPKI and what ROA in RPKI says. RARs have been operating RPKI to some degree from 2008, but recently it's for all of RARs, it's a serious service, it's a supported service. Of course, it's an ITF standard, and it was a natural step after having the routing registry. So, with RPKI, operators are in control. We show the member announcements. So this goes a bit to RIPE interface. I'm not going to talk much about that. But generally, APNIC actually and LACNIC, they both have very nice interfaces. So APNIC and RIPE interfaces are not that far, so I will focus a bit on that. If you want to create, for example, a ROA statement that basically this ASN X has is allowed to announce my prefix. If you log into RIPE portal, and I've from what I remember from APNIC, very similarly to APNIC, you can actually get a list of recommendations from either what's registered on IRRs or what's being seen in the routing table. So you can even see what's already there, and you say, if you think it's correct, then you can simply just click and create a ROA, and basically that's it, to create a ROA and have that statement out there. So here it is. On top, RIR has all the resources, and then it signs your own resource. You can sign basically your own resources, and then you can sign the ROA, which is the authorization from that resource to route for an ASN, basically comes from that resource. So if you think about it, it's mostly the focus is on the resource. You, as a holder of resource, have a certificate, and then you can sign different type of statements. In this case, a ROA, which is basically, again, I repeat, ASNX has the right to prefix my announce my prefix. Basically, comes from that certificate. So the key is certificate for the resource, which, because it's given by IANA to your RIR and from your RIR to you, that chain of holdership can be established. And here are how it works on the other side. So when you create that ROA, then you have a router, which you will connect to a validator. Almost all of these validators are easily, there is a standard protocol which talks between routers and validators, and you can easily connect them. So your router can make routing decisions. It's as simple as that. Your router receives announcements, ASN, for example, 111 announces that network, and you can check the ROAs. If there is a ROA for that, okay, then, and if it matches, then no problem, because you know the holder of that resource has authorized that ASN to basically announce their network. Here is a number of certificates in each region by RIR. So, yeah, this is RIPE NCC slide, so we're proud of it. And here is a coverage of RPKI for all our IRs. If I remember correctly, this is end of 2018. And this is basically the number of ROAs. And this one is accuracy of RPKI. If you remember, the two previous ones had a lot of red. Accuracy again means what's in the ROAs and what we see in the routing table. And you see, actually, RPKI is already pretty accurate. And that's the goal, correct? So this is mostly in our region, but for example, Belarus, 61% of addresses are basically signed, and that's an accuracy of 100%. But it's a small country, so the list is available. There is a link down there that's free, and I will have some more links later, which I will share. Recommendations: create your own ROAs in your RIR's portal, whatever it is. It might be APNIC, it might be RIPE, add-in, it doesn't matter. Just create, all RIRs support that, so create your ROAs. The max length, that's more technical, but if you have time, we will get into that. Download and run a validator. At least if you're not going to connect your network to a validator, your router to a validator, at least run a validator. And manually check the output for your network and see how things are looking. And finally, invalid equals reject. That's an important statement. So basically, that's because if you connect your router to a validator, you will have options. Assume that because your router will have to make decisions. You say, okay, I received this route from BGP. Now I'm checking via RPKI, and I see there is no ROA or there is an invalid ROA. Let's assume there is an invalid ROA. What should I do? The router has to make decisions. And you can tell your router what to do. You can tell to ignore the RPKI, just give me a notice so I can look into that manually, or you can reject. That's the most radical point. Say, okay, there is an invalid ROA for what I've received. I want to reject that route. Most people are worried, oh, what will happen to my network if I just reject prefixes I receive from BGP? And I have few statements from for example, the first two ones are from AT&T. Not all vendors have full RPKI support, or bugs have been reported, but AT&T said mostly nothing. Dutch ISP said 5 customer calls in 6 months after they did invalid reject. Another Dutch ISP said customer appreciates a provider who takes security seriously. So sometimes they see issues, but when they tell customers that's because of an invalid ROA, actually customers are happy. And a very large cloud provider, which they didn't want to be named, but I guess they were named here a few times already today. There are many invalids, but very little traffic is impacted. So our recommendation at RIPE is it's safe to say invalid equals reject, but of course it's your decision. And finally, is routing security on your agenda? If it's not, it should be, because as you saw the number of incidents, this is a growing problem. Initiate a conversation with providers and colleagues and encourage them. And finally, are you leading by example or not? That's basically it. Thank you, Paul.
Thank you very much, Kaveh. It's very good to have the view from the RIPE NCC, and I've certainly learned a bit from a few of your slides as well about the latest developments there. So I think we will move on to another review of RPKI overall with some of the development deployment issues that we're seeing. So this is Yen Xie from TWNIC. We have some slides ready.
All right. So thank you, Paul. And good morning, everyone. My name is this. Okay, thank you. So my name is Jake. On behalf of TWNIC, I'd like to say, give a big shout out to the TWNIC, APNIC, and ICANN. Without them, I cannot be here. Yep. So. On behalf of TWNIC, I'm going to present RPKI and the BGP routing security about it. So this is my next slide will be the agenda. Okay. So first of all, I'm going to introduce why we need RPKI. And for the BGP routing protocol, how do we use it? and a big deployment experience and some observations. So, before we start it, we have to know who owns the resource, right? Who owns the resource? Actually, there are lots of things worked by rumor. What is rumor? It means you thought it's real, right? But actually it's not, okay? So just like fake news, journalist gets some information somewhere and announce it as a news. And then people get that information. And we don't know it's true or not without any verification, right? So BGP routing is similar to this circumstance, all right? So I have two real cases to say that. Let's go. One day, my cousin just asked me for that. How do you prove that you are the owner of Gigi? Gigi is my motorcycle. I name it, means green and green, okay? So he asked me for this question about that. How do you prove that you are the owner of Gigi? Yeah, I got a key, right? But there is always a backup key, right? Yes, so you get a key, you cannot prove anything, okay? How about license plate number is on the back end of the motorcycle? I know the number, so what? It doesn't make sense for tell anyone I know the number and I'm the owner, right? So there's the answer is vehicle license, I think, right? The vehicle agent issues this for the buyer. And then there's an item called the owner of the car, right? So I think it's a certificate concept for that, right? To prove that I'm the owner. So how about this? One day, I found $1,000 on the sidewalk, right? And a man just shot at me, said, "Hey man, that's my money." Okay, and I just looked at him and said, "Prove it." And I got a punch, maybe. All right? So the reason why I asked him is, how do I know he's the owner of the money, right? I don't know that. There's no signature on that, right? So basically, BGP routing on internet is similar to this. Okay, when S number 65536 till 65537, that I have a prefix of that. But what is the evidence says I have that address, right? There's no evidence. Okay, there's no evidence. So, according to the RFC 4270, which is the BGP, the purpose of it is to exchange the network reachability information to your BGP peer. But the basic assumption is to trust anyone who peer with you, okay? So according to this, until now we know there's no trust prefix exchange information when we use BGP routing, all right? Actually, this slide is shared by Tashi, who is the senior engineer and as well as the trainer of APNIC. We have lots of discussion about this. And one day I just asked him for that. You have IP address, right? But how do you prove that IP address is yours, not mine, right? Where's the evidence? Okay? So some people will answer me for that. Obviously, APNIC gave it to me, right? APNIC just allocate a prefix blocks to the users, to the service provider, and there's no evidence when I receive the route according to the BGP. So right now, so what is the better way to associating you with that IP address? Okay, I think it's a PKI. We all trust APNIC or TWNIC, right? So in this way, APNIC or TWNIC will say that, give me something that I can sign, okay? So you get a private key and public key, and you keep private key secret and send a public key to the APNIC or TWNIC, okay? And then, and in this way, we can say that, as we know, a person who owns the matching private key is the owner of an address, right? It's a concept of the PKI. So here is the chain of trust. Just for your reference, APNIC and TWNIC can be a CA. So when we talk about the RPKI, we have to create the ROA. What is route origin authorization? All right, for routing, the address holder can authorize a network to originate a route information into a BGP routing system. That means when I use RPKI, I have to create a ROA. Just like AS number 65536, he have to create a ROA with prefix and the maximum length and the origin AS number. Get the permission for that. And for the BGP with RPKI, if I were 65537, I can fetch the ROA data from APNIC or TWNIC and compare with my real-world BGP routing information. Okay, compare with it. Then I can do verification for that, and then I know who is the owner. Okay? So the purpose of it is to verify who is the owner and to prevent route hijack and misorigination. So here's some statistics about the RPKI and APNIC region. It's from the NIST. And as you can see in this chart, lots of ISP in Taiwan has already created their own ROAs. Here is S3462 and 4780, right? So we take this very serious. And then we have to do, before we use RPKI, we have to do the POC and POS test for verify the feasibility. And this is our topology. And after that, you can show validation session with it and show validation statistic with the route state. And after that, you can know, you can get the validation state with the route. Here are three: valid, invalid, and unknown routes. Okay? Then, so what? You get this information, right? I think the most important thing is to have some action with this. You can still do nothing for the RPKI after validation, but the risk still be there, I think. Or you can, according to the RFC 7115, you can assign a local preference BGP attribute with a valid for higher value, and unknown routes with a low, and the invalid with the lowest. But the risks are still be there. Or you can choose drop these routes, drop these invalid routes. But some issue will happen. Users may complain about the unreachable, okay? According to the NIST, there are 6,000 invalid routes, all right? And we don't know it's truly invalid or not, but we still have to use it. So here's some observations. The first one will be the risk will still be there, except that we drop the invalid routes, which means when I receive a more specific route from my BGP peer, all right, but the prefix length is invalid, but I still use it to forward the traffic according to the local preference. And the second will be the correctness of the ROAS. Okay? Make sure that you announce the routes only after there are some corresponding ROAS, or you will get some, your upstream or peer will get some invalid route or unknown routes for that. And for the DDoS traffic mitigation, there's a situation about we want to do DDoS traffic mitigation, right? Usually we use a more specific route to centralize the DDoS traffic into the link between me and my upstream provider, all right? To centralize this traffic. But if your upstream set to drop the invalid route, then you forget to update your raw data with the prefix length. The route will be invalid. Okay, so the DDoS mitigation function will not work. Basically, it's my talk about the RPKI, but I have two more things to share with you. In Taiwan, NCC is focused on how to keep BGP network stable. So they ask us to have the baseline protection of BGP routing, and have to check the BGP route origination. So the second one is we have a TWNIC 3.0. The date will be the June 21st, right? The place is right here, the same place. So if available, please attend us, okay? Yeah, so that's my talk. Thank you.
Thank you very much, Yenxie. That's interesting. It's great to see Taiwan's moving ahead with recognizing BGP security and the role of RPKI. That's good. I think we're going to move on now to Japan, another country of the region that's been leading in RPKI adoption, and I think that Taiji will have some interesting content about some deployment realities and possibly a few problems for us to learn about. Over to you, Taiji. Thanks.
Hello, my name is Taiji from JPNIC. First of all, thank you for inviting me for a very interesting panel discussion, and congratulations for starting TWNIC's RPK service and for the cooperation with operators in Taiwan network. I am a technical guy, mainly on PKI, and I am involved in RPKI in JPNIC and JP region. But my first priority is user's aspect or user's experience. Not only from the registry. As a registry, we often introduced new technology to the users or ISPs, but if it's not useful or having a risk, we need to think about the next step. Okay, yeah, I can. My presentation is about one issue and how shoot the trouble. It's about the deploying Rov. This is ROA origin validation based dropping the packet. So if the invalid route based on using ROA, the packet is dropped, is held in some areas in Europe. This is the contents of my slides. The first is that RPKI and ROA deployment in Japan. The next is from ISP's point of view, how ISPs are looking at the RPKI or origin validation using ROA. And what will happen with Rov means that if some IAS started validation using ROA, then something will happen. And how to prepare for troubles is that after looking at the troubles by using ROA, I will talk about how to prepare for it. And the last part is what we can do. The first part is about the deployment. Before that, in Asia Pacific region, we have national level of registries like TWNIC or JPNIC, and CNIC also started their own RPK service. In IETF or the IRR meeting, we often said that the RPK service is provided by RRR, but in our region, NIR also doing our RPK service, and we have the operators community in our own region. The basic concept of RPKI is along with registries like this. The IP address are allocated to from RIR to NIR, and NIR allocates IP address to ISPs. In Japan, we are doing a trial service for ISPs on RPKI. The number is like that, and the increased number of the resource certificates are increasing slowly. But the interesting is that for IPv6, we have 56.4% coverage. And we're doing a tutorial course, hands-on seminar for beginners periodically. Root origin validation. In Japan, we don't observe the root origin validation in ISPs. Some of IX started their own validation, but they don't drop the packet. And many of BGP operators know some IS in Europe does ROV through our community meeting, like Janog or routing workshops. A decision on doing ROV in our network is hard. It was shown the previous presentation, because operational problems are unclear at this time. From ISP's point of view, this is like a magic sword. We have a recent incident, very famous incident, myetherwatt.com. We call this as a triple play. One is that the originally /23 prefix was announced as /24. And that prefix has a DNS server for giving fake a record for users. And the IP address given by the DNS server is working on with the self-signed certificate, but users often ignore the warnings about the self-signed certificate. After accessing to the faked website, the large number of Ethereum was sent abnormally. So misoriginated BGP prefix, sometimes BGP hijack, called hijack, was used to redirect to phishing site. This is like a tool to redirect the access to the malicious site. So that's why the ROA and RPKI is getting deployed. Without tools, global routing can be unsecure. And the prefix, hijacked prefix, can have DNS servers, web servers, other important IP nodes. And origin validation can be used to find the malicious root, like the My Ethernet wallet issues incident. I will talk about the one incident that is observed in Japan by using 3 slides. Customer reported to the ISP, one specific website in Europe is unreachable. But using mobile router, they can reach, and using IPv6, they can reach. Trace route, it was reachable, but it one front of destination, the AS we can reach, but the destination AS cannot be reached. The ISP responded for the customer as guiding reboot customer's router as usual in help desk. And they asked on the web form for the website about reachability. So they can access to the website, but customer cannot. And the ISP responded as asking for the S one front of the destination, number 5. Number 5 is the second one from the right side. But no good answer because no relationship with the ISP, the left side. So they asked as number 1 to 4 to help asking as number 5, but all they responded as no action will be taken because no problem found for the prefix. So as from number 1 to 4, they can access to the website. But at last, ISP got a response by email contact from found in peering DB. The reason is invalid prefix length. So they modify the prefix length in ROA. Then finally, they get the reachability from the customer to the website. But the prefix length has been changed operational reasons. And operators or organization cannot remember things over years, 2 years or 3 years after. It's difficult to remember it. So this is not the simple or just a technical issue, but will be happen in worldwide when deployment ROB. So what will happen with it? Humpty Dumpty is a character that is sitting on a high wall, and if he or she drop down to the ground, it's difficult to get back to on the wall. IP address holder may leave ROA different from actual BGP route. Then end user will experience unreachability without any final alert. Only BGP operators can know the reason, and only IP address holder, they may different from the BGP operators, can fix the problem. The different players need to react to solve the problem. So this will be the last part. How to prepare for Rov deployment. First thing is that try and know what will happen when using ROA. When unreachable for some specific routes, remember to investigate origin validation state. I think IPv6, ROA for the IPv6 is increasing in Japan, is for this, I think. The last one is my most important message. Consider communication over different NOG. Rov is a kind of new technology for worldwide. But remember, the John Foster's message, be conservative in what you do, be liberal in what you accept. When we use the new technology, we don't think the other people don't know about it. What we can do? Please understand, adoption rate is not only the indication of security. And encourage communicating between engineers and between tech and non-tech persons. Includes customer supporting staff. And spread culture of mutual help in the BGP. We need to help each other to this kind of thing, to avoid this kind of things. And without making tying the rule, not only the rule can help each other. And dropping imperfect routes using origin validation can be make unreachable IP networks. To ease recovery from the misconfigured routes or ROA, communication is important between tech and non-tech and operators beyond NOG. That's all from me. Thank you.
Thank you very much, Taiji. I think your the scenario that you described there is a very good example of what we heard before, that RPKI is a apparently necessary, complex solution to a complex problem, and it can create some real challenges in the types of exceptions and problems that it itself can turn up, which of course we need to be very aware of and careful of in diagnosis and pursuing and solving problems like the one you mentioned. We're in the early days of RPKI, of course, and so we need to be probably more aware and more ready for problems than later on. So it's not an easy challenge. Now the last panelist for the session is Kenny Huang, who everyone knows, and Kenny being the head of TWNIC and also as of this year, I think, the head of TWCert CC, so a very important security role here in Taiwan. So Kenny, your comments.
Thank you, Paul. And also thank you to all the panelists. I'm the only one didn't prepare the printing slide. Just apologize for that. Basically, most of the technical introduction has been briefing by all the panelists, but I tried to identify some of the another issue. My consideration from different perspectives. For example, I need to take off my hat as the CEO of TWNIC, as an executive council of APNIC, try to be an observer to see all the phenomena, how can things evolve and how it's going to evolve into the future. And for example, we try to allocate IP resource. That's why we set up regional internet registry So regional internet registry provide a function as an IP registry. And in order to fair allocate the resource into different stakeholders, so we need to define, identify, develop the policy. Then eventually IR become a policy registry. In order to prevent the routing misbehavior, we need to regulate that kind of route originality so that we become a RPKI registry. Like in the future, probably could be the next step could be a traffic controller to the internet. And I didn't try to elaborate something more, but somehow that kind of feature be given by internet institution basically is self-organized was without any proper delegation from some certain unknown authority. So we need to pay more attention on that kind of the governance involvement for that kind of trend. And basically, still we are facing so many challenges from internet routing, especially as Kevin mentioned, we have 12,000 routing incident happen just in 2018. And so we still try to figure out how can we mitigate that kind of threat and whether RPKI can mitigate that kind of threat, or we need to take some more aggressive action, for example, like a BGP security. But anyway, still need to go in backward one step to think about what would be the consequence. For example, routing by rumor, that's a basic principle from internet was created. All the packet will forward by someone unknown that deliver the service for you. But when we try to gradually try to authenticate any originality and all the paths from source to the destination, how it's going to become? It's going to become another uncontrollable legacy. That means all the newcomers are prohibited to enter the market because everything was in control, either by the large player, either by the government. Especially, you see some international government already intervene some of the routing security issue or jurisdictional routing. So we not only consider about the security, also need to consider what will be the consequence. We sacrifice the nature of packet switching. We sacrifice the privacy that caused by the packet switching. So we need to not only try to solve one problem from one side, we also need to consider what would be the consequence we need to pay off. That's my conclusion. Thank you.
Thank you, Kenny. I would like to see if there are any questions from the audience or any contributions and comments before we continue with the panel discussion. And I think we have Joyce. Thank you.
Hi, I'm Joyce from ICANN, but I'm asking this in my own personal capacity because I'm still learning about RPKI. So first a comment. Thank you, Kimura-san, for your presentation. I learned a lot from it because you explained RPKI by explaining the actors involved in it. So you had that example about, when a user experiences a problem and then what happens and then what is done to then resolve the situation. And it led me to think a lot of people, non-technical people, understand how the internet works from their own end user perspective, only from how do I experience the internet as I'm using it. So then my question would be, who does RPKI target in terms of increasing deployment? So let's say, imagine I wear a hat and I pretend to be a government official. And a lot of government officials are non-technical people, essentially, who are trying to develop policy on pretty technical things. So they may not always understand when we are trying to explain to them using a lot of technical terms. So how would you explain to me, as a non-technical government official who is trying to develop policy, and if I were to ask you, what do I need to do to ensure RPKI is deployed in my country effectively? Do I just leave it to the technical community? So what exactly is involved, and who should be involved? Who are the people at my table that I should involve?
That's an interesting question.
Not necessarily just to Kimura-san. I mean, I'm just to all the panelists, but I just wanted to thank him for the presentation.
Thank you for the very interesting, and we will face the situation for all players using RPKI, I think. One thing is that the story is not simple. Not saying install the new technology to your environment. This is very simple, but for RPKI, it's not said for that. The second thing is that we need to, how do we say that? If we have a new tool, we need to be used to use it. If something happened after using it, we cannot recover it. It's not a good situation. So how about this, saying the people to use a new tool? If you use this new technology, you need to used to be for avoiding the risks like this.
Thank you, Taiji. Before going to Jeff, I did hear a reference before to NCC in Taiwan having taken an interest in internet routing, and I think that's very interesting because while some regulators may take that interest, I think perhaps it's not very common. Not sure how many regulators could even spell BGP, actually. But what do we know about what's happening here in the interest in routing security at that level?
Oh, so thank you, Paul. Actually, I have experience to share is about route hijacking. There's some accidents in our network. So we receive some ISP routes, but actually it's a route leak. And the traffic is forward to them. And it's a disaster for that. Yeah. So in this case, we have to let our NCC know what is the BGP. And we tell them how we use RPKI or some kind of tech to let them know how do we protect that. But basically, there is a baseline protection about the routing prefix number for the maxima prefix. And neighbor, you have to do some ACL firewall filter list, all right? So for the prefix list, you have to do the permission, then you can receive from the ISP. So in this kind of protection, I think the BGP will work well. Yeah.
I think the question of the value for users and how regulators or governments might recognise it is very important. But it's not exactly new to RPKI because we've been having the same challenge in describing the transition to IPv6, the deployment of DNSSEC, and now RPKI. So we really do have challenges here in describing how we're going to make the internet a better place by improving a lot of invisible but important stuff in the background. Jeff, were you wanting to comment on this topic as well?
I was wanting to comment on this topic, and I was actually going to follow up from the analogy that Jack had produced in his presentation, because I think it actually gets right to the heart of it. I liked GG the motorbike. Because in actual fact, there are two questions. Who owns the motorbike? And does Jack have the authority to put it on the road? Driving it and owning it are actually two different things. And even driving it correctly, on the correct side of the road, is it on the right or the left here in Taipei? You know, is the third question. We confuse RPKI because we bundle up three things, I think, and talk about them as one, but they're not. From APNIC's perspective, we are trying to make who is more provable. Is that your address? Prove it to me. Give me a signed attestation that only you could have signed that says it's your address. And in and of itself, that is really critical for policymakers. You know, are my ISPs routing the right addresses? You know, and that's the first thing, address integrity. is it my motorbike? The next question, am I allowed to drive it on the road, is actually a really hard question. The rowers and BGP is work in progress. We are encouraging operators to do this, but I think everyone will admit what we're doing today might not be what we're doing in 5 or 10 years' time. There is a lot of feeling about the operational requirements of BGP and the operational requirements of security that we're still feeling our way with. We encourage people to use it, but it's not going to cure all routing ills. Humpty Dumpty will still fall off the wall sometimes, and you know that's a problem. But there is a big distinction. I just wanted to highlight because it's really important. Owning it and using it, even in IP addresses, are different things. RPKI helps with both, but they are different. And just remember that distinction and it'll be a little easier.
So maybe the answer here is whether it's talking to end users or to governments, that analogies can be very powerful, and again, governments are very well experienced in understanding different aspects of society, and probably the license to drive and the license to use a car, etc., is a very good analogy.
Exactly.
I suppose if there's anyone from Singapore here, they'd understand how expensive it is to obtain what's effectively a rower for your car in Singapore. William.
Hello, everyone. I'm William, also from Taiwan NOC, TWNIC. And I want to ask a question about, because we have our company and Taiwan community has been learning about RPKI for a long time. And we all know the benefit of using RPKI. But I just wonder, because in Taiwan, the government, the NCC is trying to ask all the ISPs to deploy RPKI. One question is that, is there any other countries in the world that the government is enforcing or just mandatory asking all ISPs to deploy RPKI? And is there any other countries, say China or Russia, are they strongly request no ISP in their country can deploy RPKI? I think that's the question I have. Thank you.
Yeah, I'm not speaking on behalf of the other country, but I just try to correct your verb. You say enforce using RPKI. Basically, it's not enforce. Just give you a cup of coffee and try to convince you, please do that.
And APNIC will give you a free T-shirt as well if you do your rowers. But I think government action or recognition is very important. I'm not sure if Kaveh knows of anything in the RIPE region, or if David might know anything from the ICANN perspective.
So I'm not aware of any country that's banning use of RPKI. To my knowledge, actually, there must be one network in almost every country, but we can look at the stats. But to enforcing, yes, because there are a few countries, at least in our region, in the Middle East, and also in Central Asia, which there is only one provider, which is owned by the government. And when they enable, correct, basically the whole country has RPKI. I think, actually, I'm not 100% sure, but I think the case of Belarus, which I showed you, is one example. But there are a few in Middle East as well where there is only one or two operators which are allowed and licensed to provide internet, and both of them have RPKI deployed. So.
The question does remind me about one of the reservations that has been expressed about RPKI, which is the creation of another hierarchy, like the DNS hierarchy, which potentially gives some points of control to the people who hold the trust anchors effectively, and that has been an issue with RPKI, which I think Kaveh, you were interested to talk about, whether this is a centralization or not of control.
Yeah, so I think it's continuing on what Jeff also mentioned. Naturally, there is a need for some hierarchy because IP address is the way they work, and you want uniqueness. So there is a hierarchy there, which they come from IANA to your RIR to possibly NIR and then to you. So having certificates attesting to that I think is fair, because hey, you have a resource which is coming from a hierarchy, and there is a certificate which says you hold that resource. Basically, the that certificate of ownership, correct? Or holdership in this case. But then having the ROA, which is a statement on top of that. So you hold this resource and then you make a statement. Now that's also, again, as Jeff mentioned, is done by RIRs. But there is no necessity for that part. We are doing it and it's working fine, but that means RIRs are now part of operations of basically your routing, because if it fails, there will be a problem as well. So, and the other thing that actually I'm very happy that APNIC is pioneering that is the idea of being able to sign anything with your certificate. Because if that happens, basically your certificate of holding a resource becomes, to put it loosely, your key to SSA, correct? It's anyone in the world can come up with a service and say, hey, if you want to use this service, you have to prove you hold these resources. And then they can be creative and innovate as much as they want, because they can say, hey, we can come up with a anti-DDoS service as long as you say we create a registry of people who did us and people who want to filter, but you have to say we have to make sure you hold these resources, correct? There are indefinite possibilities of that. I think that would be the right level, but at the moment anyways, operationally, RIRs are part of also creating signing of the ROA and also distributing that. There are also solutions to that, which I know Paul is also following, but I had two things to say. First, I think the model that RIRs also being part of routing operations is not sustainable. It will work, but I don't think in the long run that will work, and that will naturally evolve. But the second, for that to evolve, we basically need as many people as possible, as many networks as possible to adopt RPKI, because then the issues will become more visible, and of course then the solutions will become more relevant. If today someone comes up with a solution, there is not much need because people haven't even used what's already out there. So first is we really need to focus on adoption, but the future I see is I think the role would be more to focus the certificate of holdership, and the rest would be decentralized by different mechanisms.
Thanks, Kaveh. We've got a few more minutes left if there's another question. If there's not, then perhaps if any of the panelists have got anything final that you'd like to say, either in response to the discussion so far or as a final remark, then please go ahead. Yanqie?
I'd like to say that why we do keep seeing the problem with the BGP routing. I think the main problem will be there is no one is in charge of that, right, for the BGP routing. And when you want to do it beyond this topic, okay, when you want to do the BGP monitoring, how do you know the BGP routing table currently you use is correct, right? We don't know yet. We have to know, is it correct or not? But we don't know that. So it's some kind of bootstrapping problem. We just can use the resource allocate from the APNIC IR region, and they allocate the resource for us and sign it for the ROA, right? Then we can prove that we have the evidence shows that I own this prefix or IP address, and then we can use it to do the routing protocol, announce the route. So I think it's a quite basic fundamental concept for the BGP routing. Keep this BGP routing security is very important right now. Yes, I think.
Okay, thank you. I'll skip to Taiji.
Actually, my key message is mutual help. The ROA and the ROV is a kind of complex, but if we have the communication channel between like Taiwan and Japan, or Europe and Japan or Taiwan, then we can solve and we can go forward, I think. So communication is my message.
Okay, thank you. Kenny?
Okay, thank you. Yes, we do. Yeah, thank you. Yes, also encourage people not only sign the role, but also activate your validator, because most of the ISP in Taiwan already signed a role. And I encourage many of you, if you don't have a routing validator, you can use TWNIC routing validator. That's the first point. Okay, but secondly, also, Internet has more than 700,000 routes already today. And I remember regularly update every day with about 170,000 update regularly. According to the data, basically, I don't think this is human readable topology. So ask the robot to hand over BGP security instead of human or senior engineer to taking over the BGP security will be more secure. Thank you.
Kavi.
So I have 3 quick points. One is one thing which was not mentioned. Of course, RPKI doesn't provide full routing security. It's a key element, but of course there are also a host of other possibilities, types of attacks that can be done even if RPKI is in place. So don't think that's the full suite. If you enable RPKI, your routing is secure. Of course not, but that's a very viable first step to securing routing. And to continue that, actually, I really liked 2 points. So that's my next 2 points from Kimura-san's presentation, last slide. One is basically adoption doesn't show security. Keep that in mind, because me as an RIA representative, I like to go around the world and say, hey, we have this many, and show this up to the right numbers. But it really doesn't show. Back to the first point, it might even be 100%. That doesn't mean routing is secure. So keep that in mind. And also, RPK adoption is tricky because you have to look at both sides. It's how many people have signed, and then how many people are doing validation. So it's also a tricky thing to get. And finally, again from your points, and thank you, it's the mutual help, because that's basically how BGP works in technology. And we humans, if we want to make it really perfect, we have to basically follow the same. So let's collaborate, let's talk to each other, and let's share experiences. That's exactly how we can mature this and make it better and better. Thank you.
Thank you very much, Kave. I think something that's really occurred to me during this series of presentations is, again, how we're in the very early days of RPKI. So we've heard several different ways to explain and explore RPKI from different panelists, including myself this morning. And I hope that's actually been useful to look at RPKI with the different analogies and different ways to explain it. What may be less useful is that I personally noticed quite a few inconsistencies in some of our measurements, and we'd have maybe expected some of the global measurements to be converging on something consistent these days. But I think that's also just simply showing that, again, that it's early days, and there are different ways to purportedly measure something that should look the same. So I'm not sure if anyone else spotted those deliberate mistakes, but I think that's the lesson, is that we have quite a long way to go, that it's early, that the RPKI is complex, and that many things, I think Taiji mentioned this, many things will be discovered in the implementation, that until we actually use it and get used to using it, we won't know what direction things are taking as time goes on. And Jeff also mentioned this, that the way that we're assuming that RPKI is going to be used today and the way it's being implemented today may well change. Something I've stressed a few times in relation to the IPv6 transition is that we don't actually have a test bed for the internet. So we actually are deploying on the live network and not really learning fully until we get closer to full deployment. This actually puts an obligation on everyone to actually participate, because it's by getting used to it and deploying it that we will actually ourselves learn and contribute to the learnings of others. So for those in the audience who are in a position to start using RPKI, even the very early step of certifying and registering ROAs, that's an easy thing to do. As Kenny said, that's only part of the story, because by certifying your address space, you're just making the certification available for others to use. And so the other side of it is that if you're in a position to validate routing in your network, then that's a step that you can also take, and that by taking those steps you can improve you can bring some improvements for your own security, but also contribute to the overall process of securing the internet, because this is, of course, very important. We don't need to say that anymore, but it is also early days. So let's see what we can do to move this forward. I hope this has been an interesting and useful panel. Thanks to everyone for your presence and attention. Thanks again to the panelists. Thanks to those who asked some interesting questions that helped the discussion. And I suppose that concludes the panel. Thank you.